In this example, we will use composition to verify inverse functions. We are given two functions named f of x and g of x. F of x equals x cubed minus 1, and g of x is the cubed root of x plus 1. And the composition rules state that to determine if two functions are an inverse of each other, if I use composition, both of the solutions that I will get for f of g of x and for g of f of x should both equal x. So we are going to prove and show you that these two functions are inverses of each other because when I apply composition in both directions, the solution will be x. So let's do f of g of x first. F of x is the function x cubed minus 1. But where there is an x, I will insert g of x's function, the cube root of x plus 1. So here we'll have the cube root of x plus 1, but in f of x, the x term is cubed, and then we'll bring down the minus 1. And when I simplify this function, this simplifies to the cube root of something raised to the cube power, takes care of the radical for me, so that simplifies to the terms left as the radicand, which are x plus 1. And if I bring down the minus 1, x plus 1 minus 1, the 1's cancel out, and this simplifies to x. So we've done half of the process. We've shown that the composition of f of g of x is equal to x. And for this process to be complete, I need to show the same thing in the other direction, that my solution is x. So let's go the other direction. We're going to find g of f of x. So we start by saying, what is g's function? G's function is the cubed root of x plus 1. But where there is an x, I'm going to put what f of x's function is, which is the x cubed minus 1, and then we bring down the plus 1. So as you already know, x cubed minus 1 plus 1, the 1's cancel, so that leaves me with the cubed root of x cubed, and again, using our rational exponent properties, the cubed root, same index as the power that the radicand is raised to, is going to simplify to x. So we've shown here with composition that this is how you verify that one function is an inverse of another by doing their composition in both directions. And if the solutions are x, then you have verified that they are inverse functions. So again, in this example, we have shown using composition that two functions were an inverse of the other.